Okay, these are from section 3.1. So to do 51, we're trying to isolate the variable. We're trying to solve for the variable. The opposite of multiplying by 5 would be to divide by 5. Whatever I do to one side, I have to do to both sides. So when we divide, we end up with x to the third on the left. This gives me 216. So that's x to the third equals 216. To get rid of the third power, you're going to do the third root. If you do it to one side, you do it to both sides. The third power and the third root eliminate each other, and we're left with the third root of 216. So let's see if any number times itself 3 times gives you 216. So apparently 6 to the third is 216, so the third root would be 6. Not plus or minus because it's not an even root, just 6. You can also think of it as raising it to the reciprocal power. Raise both sides to the 1/3 power. When you do a power to a power, you multiply your exponents. So that gives you the x that you're looking for, and you end up with the same result. Angelina, you'll tell me when you're ready, right? Okay, after 51, we're going to look at 53. To get rid of a fourth power, we have to do the fourth root. If I do it to one side, I do it to both sides. The fourth root is the same as raising it to the 1/4 power. I'm doing the same problem parallel to each other. One using the root, one using the fractional exponent. So I need the fourth root of 256. So we have 4 to the fourth being 256. So the fourth root of 256 is going to be 4. If you ever do an even root in an equation, just like you have here, an even root and it's an equation, you need to put plus or minus 4. So that means x minus 5 will either equal positive 4 or x minus 5 will equal negative 4. If you add 5, you get x to equal 9. And if you add 5, you'll get x to equal 1. Now, whether you did it with the fourth root or the fourth power, 1/4 power, we should get the same result. Power to a power, you multiply your exponents, so that really just makes it into x minus 5. 256 could be called 4 to the fourth and to the 1/4. So you get 4 to the power to a power, you get a 1. However, again, you have to remember it's an even root, so you put plus or minus. And then it's the same result from there out. Let's take a look also at 55, I guess. Opposite of trying to isolate the variable, opposite of multiplying by 7 would be to divide by 7. So that gives me x to the fourth equals, I believe that's an 8. So I have to get rid of the fourth power by doing the fourth root. So if I do the fourth root of one side, I have to do the fourth root of the other side. So that gives me x. It's a fourth root, so in an equation, so I know I need plus or minus. What do we have? I guess the fourth root of 8 could be called 2 to the third. So I don't know how they're going to write this. Let's check. You could write it as power over root. Okay, some more questions from 3.1. The third root of 8, which happens to be 2, raised to the negative 2, means you move it to the other side of the fraction and turn it into a positive exponent. Number 41, you punch into your calculator. So I punch this into my calculator. I get this digit, 0.0113402. It says to round to 2 decimal places. That 1 is not going to round it up, so the answer they have is 0.01. Okay, how about the fourth root of 20,736? So 2736 raised to the, so if you're going to type it into your calculator, many of your calculators have this to raise to, and I would make sure you use a parentheses when you have fractional exponents, depending on whether your calculator has what's called pretty print or not. But this gives me a result of 12. Now in this one we want the nth root of a, so that's the fourth root of 0. What number times itself 4 times gives you 0? Well, that would be 0. Okay, how about number 29? We want the fourth root of 16. Well, the fourth root of 16 happens to be 2. So that becomes a negative exponent, moves to the other side of the fraction. I need to know 2 to the 7th, so that happens to be 128. 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th means times 2 again, 64. I don't know why I wrote a 6 there. It's 2 to the 6th, 2 to the 7th is 128, which is what I used here. These are important because we live in the binary age of computers, so powers of 2 become fairly significant. So significant that you should know higher powers. 2 to the 8 would be 256. 2 to the 9th would be, 512. And 2 to the 10th, I believe, is 1024.